All right. Good afternoon, everyone. So just a very kind of brief introduction to myself before we jump into this. I am the solution lead for our data and AI practice at Covenant Technology Partners. And we'll talk a little bit towards the end about who we are and what we do. But just as a general introduction, I've been involved in data and analytics in some capacity for I don't know, nearly 25 years now. So I guess that makes me a little older, but I've been doing this for a while. And mostly I've been doing this in the Microsoft space as well. So today we're here to talk about Fabric. Fabric is a brand new announcement from Microsoft. They announced a build at the end of May, and it's currently in preview, and we'll be going over kind of what Fabric is. I do have a little bit of a just quick summary for those that are impatient and don't wait. So it is a unified software as a service solution, and we'll talk about what all of these kind of buzzwords mean inside of this. But they're billing it as the data solution for the AI era. And we'll talk a little bit about what that means, why that may be significant, why it might not be significant as well. But really what Fabric does is it brings together a whole lot of different components into a single suite and allows us to kind of deliver our what we would have used to call business intelligence in a much more clean and unified and open way. And I really do believe this has some potential to revolutionize how we do data analytics, and we'll talk about that a little bit as well. But before we get to Fabric, what I really would like to start with is kind of understanding the evolution of analytics. And so we're going to go through a little bit of a history lesson, I guess, here, a little bit of a timeline. It's going to be condensed and fairly brief, but we want to go back to the beginning so we can understand a little bit about where Fabric came from, why it may be seen as special, and why it's different than maybe how we've been doing analytics for the last decade or so. So to start this off, though, I do want to kind of give a little bit of a simple, very simplified working definition for what I'm talking about when I say analytics in this specific scenario, because it can mean a lot of things to a lot of different groups, a lot of different organizations. But from my perspective, what I'm talking about here today is just this very simple idea that we are taking data and we're turning it into some sort of actionable insight. It's really that simple. All of the other kind of semantics about that don't particularly matter when we're kind of going through these quick history lesson. It doesn't really matter how we're doing it. Doesn't matter what the tools we're using to do it, really. It's just that is the concept here. Is we have data and we need to be able to get something out of it that is actionable. So we're going to go way back to really kind of the dawn of computing. It's kind of ironic to me because over the last couple decades we talk about the explosion and the volume of data and so forth, and it's a driver for things like big data, things like cloud computing. But really, from day one, we've had a data volume issue. From the moment we started with computing, we started creating amounts of data that were not necessarily easily analyzed from just a human perspective. And so it was a problem really from day one. And that problem led to these kind of early concepts around decision support systems. It was first coined, I believe, in 1964 by this Michael Scott Morton. He was a professor at MIT, and he was really one of the key kind of people responsible for forming what was later known as MIS, or Management Information Systems. And this concept of a decision support system came out of that. And to give you some examples of what an early decision support system would be like is using mainframe computing to plan out, let's say, airplane routes for an airline. So instead of person manually trying to figure out which planes were going where all over the world, computers were now modeling that and giving decisions around the planning and the scheduling of those type of systems. So at least initially, and I think you'll find this pattern falls forward in every decade that we're going to talk about, that the reporting side of this, kind of the getting the data out of this side of it, was always led by some sort of operational need. The analytic side of either looking back or looking forward part of it came later. So we had some sort of operational need, like the flight scheduling for airlines, that then led to some level of backwards and forwards looking reporting. These early systems, you need to understand, this is all pre-database. There was no such thing as a database at this time period. So they were very much manually coded just to fetch data, to kind of munge that data together and give you some sort of report back. And these reports, very early reports, were all structured. There were things that were printed out. They were maybe summaries of the data that were occurring. And at best, they were maybe based on very simple kind of mathematical models. So there really wasn't any sort of advanced data science, as an example, at this point in time. And the focus, again, was more on why something happened, as opposed to the forward-looking what if. That what if scenario really didn't exist as a concept yet. So as we move into the 1970s, we really get kind of the birth of, well, databases, and more importantly for our purposes, relational databases. So in 1970 is when Codd kind of introduced his initial writings and papers on what a relational model might look like. And it took a while for some of this to catch on. IBM, who Codd was working with at the time, is who kind of released the first kind of prototype relational databases in the mid-70s. And this is also when we get this initial concept of entity relationship diagramming as well, which is important later because it leads to kind of our concept of data modeling for analytics. And at this point, this is when databases became kind of a core feature of decision support systems, but there still wasn't any concept of business intelligence yet. It was still this concept of a DSS. Another important thing that happened in the 70s, good, bad, or otherwise, was the introduction of spreadsheet software. Because VisiCalc, I think, came out in 1979 and was the first spreadsheet software available. And then, of course, that exploded into a whole bunch of other software into the 1980s, which ultimately led to Excel, which ultimately led to Excel Hell and all the other good things that kind of come around with that. So in the 1980s is when the concept of business intelligence really started to form. And it was built around this kind of golden age of the relational database management system. This is when all of the major database systems were born in one form or another, everything from Oracle to Informix. Again, they may have had roots back in the 70s, but at that point, it was really more about prototypes or one-off solutions, as opposed to building it into a packaged product that we can sell. The other major advancement in the 1980s early is the introduction of SQL. SQL as a language, and the idea of having ACID principles in a database. Hopefully, if you guys have a database background, you understand ACID and understand the importance of SQL as a querying language. But all of this was brand new in the early 80s. And this explosion of this started to lead to purpose-built systems specifically for business intelligence. And what we first see on kind of the market displacing these legacy DSS systems is this concept of an executive information system. This is also the first time we start seeing more of a graphical representation of data from a computer perspective. So we're seeing charts. We're seeing, the venerable, pie chart specifically was one that kind of came out of this period from a computer perspective. Again, all of these things existed on paper and so forth prior to this, but from a digital perspective, this is when these things were born. This is also a time when OLAP was born, which is going to be key to the 1990s kind of view of business intelligence and this move of business intelligence around the concept of data warehousing. But the idea of data warehousing itself was born in the 1980s. Bill Inman referred to this concept, and he started really solidifying what it means to build a purpose-built repository just for the idea of integrating data across all of these operational source systems. So I think it was right around 1984 that the data warehousing term was originally coined, and it kind of went from there. And in 87, as I have noted here, is when we see the first printed use of the word business intelligence. So that brings us through the 80s. So into the 90s, data warehousing becomes the de facto standard for doing any sort of large scale analytics. And this is oftentimes driven by the improvements around OLAP technologies. This is where you're going to see the birth of things like SQL Server analysis services, but it's also where we get a whole slew of the major kind of traditional enterprise tools, everything from Cognos to MicroStrategies to business objects. They were all kind of born in this time period. And this is also the heyday of kind of the Kimball dimensional modeling. So we've finally kind of moved from that base ER diagrams with like things like third normal form and very relational database models into more of an analytic purpose-built data model. And again, this becomes very, very important as we move into the 2000s and so forth. And data warehousing continued to dominate the space. There was absolutely alternatives going into the 2000s and so forth, but it is dominating it at least until the teens or so in the 2000s. So what we end up with is an architecture that looks something like this, where we have these incoming spokes from various source systems going through some sort of ETL process. And again, this could be defined differently depending on what kind of enterprise suite we're using, but it would go through this processing portion, and then it ultimately lands into our data warehouse. In this particular model, the data warehouse is split a little bit. We have kind of a traditional operational data store, we have some metadata, and we have more of a formal enterprise-wide data warehouse at the top. And so the complexity of this, or the lack of complexity of this, is going to be based on kind of the maturity of your organization's BI architecture. But ultimately, this is the kind of end goal that we're going for. And then we have a bunch of outward spokes that are delivering this data to end users via reports, via ad hoc type of interfaces, and so on. We also then see a pretty big shift in the life cycle of what an enterprise data warehouse looks like. And this is just kind of the general waterfall with multiple path approach that Kimball's lifestyle toolkits kind of came out with. And this, again, was the predominant way of delivering these things well into the 2000s. But when we combine that previous architecture, actually, I'll go back here a second and talk about some of this, we start to see some cracks forming in this from an actual implementation perspective. You see organizations like Forrester coming out with reports talking about upwards of 70% of data warehouse projects are ending in some level of failure coming out of this. And you start to really hear that there's a desire to come up with something that is better than what we've been doing at this point. And some of the drivers for that we'll get into in a couple slides, but it's really the monolithic nature of this and how strongly coupled all of these kind of pillars are. I can't easily just pull out a section of this and replace it with something else without destroying maybe the whole kind of downstream process. They're very tightly coupled, and that becomes part of the problem with it. And the amount of time to go from an end-to-end data warehouse solution is usually measured in years. That's another part of the problem with this, is you would disappear in a project, spend 18 months plus developing this thing, deliver it back to the business only to find the business requirements have changed or you missed them altogether. And that was a very big lead to what is the failure that a lot of these analysts saw in kind of the 2000s era. So let's skip ahead. So we had these drivers for something different. The first driver I'm already kind of alluding to is this ability to be more agile with this. And I don't mean agile from a development methodology perspective, but being agile and being able to react to our business needs very, very quickly. Our ability to go in and experiment and fail fast if we are going to fail so that we can move on and do the next kind of thing that's going to address it. Cloud also starts to become prominent during this kind of time period where the appetite for buying these very large, let's say, appliances and so forth to do these data warehouses starts to sour some. And we were looking for solutions that are a little more on demand, that we can provision quickly, again, to lead to some of the agility, but it also has to do with just reducing the overall upfront cost of this. And then ultimately, it does lead to cost. And that's kind of this ROI pillar at the end, is we don't want to wait 18 months before we have any sort of value on it. We want the value next week. And we want to lower upfront investment to get to that value next week. So these things really started to drive a need for something different. And that need for something different, I think we squandered quite a bit of time going back and forth trying to figure out what that is. The other one that I didn't have on the previous slide, but in this first bullet kind of talks about it, is there was really an explosion of data with the internet and a lot of other things behind that, where our previous kind of systems that we've been using just could not keep up with the processing that we're looking at. And so this led to some new advances. One, it really led to kind of the golden age of appliances with things like Teradata, but a whole bunch of other organizations as well developing data warehousing appliances that could be scaled out to handle some of this. But it's a bolt-on of that traditional enterprise data warehouse, just now with a massive hardware backing in order to kind of brute force our way through some of these previous issues that we had mentioned. The growth of web also pushes us towards a lot of these NoSQL databases, with the early kind of advent of things like Facebook and Google and so forth, where we start seeing that pop up as a technology stream and starting to be dabbled with in analytics as well. And then finally, it all kind of leads to these big data technologies. Primarily Hadoop is what we'd be talking about here. But the real big problem with this was in many ways, these were steps backwards. We lost things like ACID as a principle, and there's a number of other things that were kind of missing in the early versions of these solutions that did not make them ideal for large scale analytics in the end. Didn't stop us from building it, didn't stop us from attempting these things, but the success rate on this really wasn't much better than the success rate was previously with data warehousing. In parallel to this, on the back end, on the front end, we have kind of the rise of self-service during this time period. So this is where you see companies like Tableau emerge, companies like Qlik, and you also see Power BI being released from Microsoft. And their focus was much different than the back-end focus that we just talked about. Really, their main method of attacking these problems was just to go around the problems and kind of ignore them. And let's just go directly to the source. We'll pull some data in memory. We'll crunch it together. We'll get our answers. We'll achieve that agility. And it works. It has been working. This is what we've been doing for the last, decade plus at this point with a lot of this tooling, is going around, and where need be, we adjust some of these back-end systems to help support the front end. But the main goal of the front end isn't there to interface with that kind of back-end data warehouse. It really is to usurp it and kind of go around and come up with ways of getting access to the data much, much quicker. And ultimately, where this fails is at scale. The ability to govern these type of environments, the ability to apply policy becomes pretty difficult. And this is still a problem that we're dealing with right now today, is how do we have proper governance in some of these environments when end users may be generating thousands of reports and we have no idea the quality of the data or where it's coming from or any of that. So this back end kind of revolution and also this front end revolution really leads to this emergence of what we started looking at from a concept of a modern data analytics engine. And there's three primary characteristics that we see in these kind of architectures. One is that they're modular. So we can take the best of all of these kind of components, merge them together, and get the features and functionality that we want. So maybe the best for us from a data warehousing perspective is something like Snowflake. So we would use Snowflake as our data warehouse engine, but we would use something else maybe as our ingestion and kind of ETL engine that would kind of plug into this. All of these systems are also being built around the concept of them being elastic. Some of this is for cost control, but a lot of it is also just being able to burst up based on demand. So instead of having to design a system for the worst case scenario, we can design the system for as what we need today, and we will burst for those worst case scenarios and bring it back down when we need to. And ultimately, coming out of kind of the big data world, we end up with this idea of data being very fluid. We want these systems to be able to handle any type of data at virtually any rate and size. So very, very large volumes of data, very quickly changing data, all of it needs to be able to come into this. And this is kind of the model that we've been delivering for probably about 2 years now from that kind of perspective. And it takes things like, again, there's a lot of players in here, things like Databricks, things like Snowflake, things like Microsoft Synapse, and it combines a lot of this together. From an architectural perspective, we also see this kind of emergence, and this comes more out of the cloud application side, but it starts getting applied to analytics and data warehouse as well, where we have a compute and storage optimized architecture, and that we are separating the two. Our storage becomes static, and it lives somewhere in the cloud, and we can grow it, shrink it, we can do things to it completely independent of the compute. And ultimately, our goal is to be able to take compute to it. The appropriate compute. If we have a big data workload, we might bring Databricks to it. If we have more of a traditional kind of data warehousing role, we might bring again something like Synapse or something like Snowflake to it. But we bring the compute to the storage, trying to reduce multiple steps of data movement. And what this looks like in practice, what we are living with for the most part today is an analytics service that is a platform or a series of platforms that, again, they're modular, that we can kind of plug together. So this is where you see, organizations like Databricks play in this. Databricks lives in all of the major cloud environments. They are agnostic in that sense. So our data can live in AWS. We bring Databricks to it. We process the data. We do what we need to do. And then we can kind of move on. And these are also semi-managed solutions, where a lot of the complexity of the back end, the infrastructure side of this, is managed by these organizations for us. And there are a lot of benefits to this. And adoption has been pretty rapid for a lot of organizations today, but it does come at a cost. And the three kind of pain points that I point out here is, one, the architecture can be very, very complex to design and manage. You have to understand where all the integration points are between, let's say, something like Databricks and Snowflake. And that burden of managing all those integration points falls on you. The Databricks and Snowflake teams, they're not helping you necessarily with it. They may be giving you some tooling to assist with it, but you're ultimately responsible for building how these modular components interface with one another. And the last kind of big portion of this is the pricing models that fall out of this. Every single one of them is priced differently. Sometimes they're priced differently within even the same product, where you may have models that are based on some sort of threshold, and you breach that threshold from a consumption, and then reverts to some sort of hourly metering. And then that may also be based on how the systems are scaling out. So how many instances did we need for this compute? Was it 2? Was it 200? All of that starts making the pricing models very, very complex and hard to manage. And again, that burden of managing this falls on you. Microsoft doesn't particularly care if you ran up a $50,000 bill this week. It's your responsibility to make sure that the guardrails are in place, that cannot happen by spinning up a bunch of compute. And again, these organizations do give you tooling to be able to manage that, but it is still your responsibility to utilize that tooling to build it all. And it, again, becomes pretty complex. And so some of the promises that came out of this was the ability to start really quick, start very small, and really kind of democratize this access to analytics. So you didn't have to be a giant enterprise organization to utilize these tools. And that is true, but it's those smaller organizations that are least likely to maybe understand some of the complexities here or be able to properly manage some of these costs. And so they start playing around in this environment, and they're the ones that all of a sudden get that big bill at the end of the month, and they're like, oh crap, now what do we do? And so again, I don't want to downplay this too much, but this is all leading into what we're going to talk about next, because this is where we are primarily playing today. And there are a lot more tools and components to this than what I'm talking about. This is a much, toned down and simplified kind of discussion of this. But all of them are kind of playing in this platform as a service kind of analytics space. So thank you for bearing with me here, because now we're finally to Fabric. So Fabric is based on these same exact concepts, and we will get into it, but Fabric is approaching it from more of a software as a service solution as opposed to a platform, where most of the platform elements are going to be managed by Microsoft. And their kind of tagline here is it's all your data, all your teams, all in one place. So we take previous Azure concepts like Synapse, Data Factory, Power BI, and they all get merged into Fabric. And we'll be talking about each of these kind of experiences and components here in the next couple slides. But this is ultimately what the components are to Fabric, and it's all under a single unified model. So we have everything from the data movement aspect all the way over to the visualization side of it. So in order to understand the Fabric, we really need to understand kind of the foundation of Fabric, and that is OneLake. And OneLake is a new concept for Microsoft. It is, again, foundational to what Fabric is, but it technically isn't Fabric. It is just a component of Fabric, and it's a part of it, and it's a part of it that can actually live separately to Fabric. But let's go over some of its key characteristics. First, it is a data lake. It's a data lake based on Azure Data Lake Gen 2. There are some differences here, primarily when we start talking about the management side of it, because again, that burden of managing this environment is not on you any longer. That burden is now on the service itself to do it. It mimics an open source platform in the form of the Hadoop file system through its APIs. So tooling that can communicate with a Hadoop file system should be able to communicate with OneLake and Azure Data Lake directly. So it's open in that sense that you don't necessarily need to utilize Microsoft's tooling to write to this platform. So where it starts to deviate from Azure Data Lake is in kind of this next bullet. It has a global footprint. You have one lake per tenant, and that lake, in theory, it's logical. It expands the entirety of the globe. It doesn't really care where your data lives, and we'll talk about that in the next slide a little bit. But I can have data living on-prem and be part of my OneLake. I can have data living in AWS and have it be part of my OneLake. It can be living in, a web service somewhere, and I can link that into OneLake. The other big change, again, from Data Lake, though, is how this is organized. So Data Lake in Azure is primarily based on Azure's kind of storage accounts, the blob storage that is kind of that legacy system that's been there since the beginning of Azure. And that is organized into containers and organized into file systems for Data Lake. The way that OneLake is organized is actually taking a page out of kind of the Power BI playbook here, and it organizes these things into workspaces. Really, it's just a kind of a difference in naming and a difference in how it's managed. It really ultimately ends up being the same, where workspace is essentially a container inside of your storage space. But it's important to understand that there is a shift in perspective of how these things are organized and how they're managed. So getting back to that idea of global. So OneLake introduces this concept of shortcuts, just like you can create a shortcut in your file system on your laptop or whatever. And that shortcut can then point just about anywhere, as long as you have somewhere some sort of network connectivity to it, I can shortcut to it. So it could be an S3 bucket that I'm shortcutting to, and I have data there. From the OneLake perspective, and any user that's using OneLake, it just looks like it's data inside my OneLake. There's no concept that this data is outside of Azure. It doesn't matter, doesn't care. It's still considered a first-class citizen. I can query it directly. I can, if I have appropriate permissions, I can modify it, I can add to it, whatever needs to be done, even though it lives outside of Microsoft's cloud. Does not matter. And so you do have this ability to have this really true kind of global footprint for this. Now, I would point out that there's definitely networking concerns and so forth, that transitioning between clouds may cost you more because we have some egress of network traffic. It may also be slower than if it was natively inside of Azure. But in general, the performance has actually been pretty good with this in the preview, and it just works. So all of that said, though, even though we have this concept of this one single global lake, OneLake does also support the concept of data residency. So I can force data into certain regions of the world. So if I have government regulation requirements that require my data that exists in the EU only, I do have the ability to kind of pin that data into those spaces. It'll still show up to an end user as though it's just part of your global lake, but you can build some policy and stuff around it to keep that data in the territory that you need it to be in. So a few more features here. There's a unified security and governance and policy layer. This is called One Security. I will point out that this is probably one of the least mature areas of this product at the moment. A lot of the features and functionality for One Security are missing, although they have been starting to show up over the last couple of weeks. But the idea is we have one single plane of management of security. If I tag data in my lake as being highly confidential, that flows through to all of the tools. So all the way through to Power BI. Power BI sees that it's highly confidential, and I can apply policy for access to that or how it is treated. Can I export it? Based on the policy, I might say no, and it'll stop me from doing it. The other key factor to OneLake here is it's really getting positioned as kind of a replacement for OneDrive to some degree. There is a File Explorer extension for Windows available for OneLake that I can just drag and drop data between my desktop and OneLake and have it sync out there and be shared with everyone based on, workspace access and the permissions that I have. So I could use this to store whatever documents and stuff I want. And again, in theory, as long as the document has some level of structure to it, it's queryable. And so it does kind of bring that OneLake experience all the way across. Before we move into some of the other aspects of Fabric here, though, what we do want to, I guess, look at is there are some key kind of storage concepts that are built on top of OneLake that become really important for the downstream experiences. And this is centered around these two assets that you can build in a data lake. The first is a lakehouse asset, and the second is this data warehouse asset. And we'll get into a little bit of detail about what makes these different and why you might use one over another and what they are. But the main thing to understand is that it's a logical representation of our data that's stored in our lake. And it is based on an open standard. Specifically, it's based on Parquet files that are organized into the Delta framework, which has been pioneered by Databricks. And so this is what brings ACID compliance to our kind of big data lake world and allows us to be able to do things like transactions with our inserts and updates and guarantee that kind of ACID compatibility. Why this is key to everything downstream inside of Fabric is this standardization around this single kind of storage mechanism means that every other tool in this environment knows how to read this, and not just read it, but it's been optimized to be able to read this. this is really important when we talk about SQL Server, because normally we think of SQL Server as being a kind of a confined data platform, and that SQL owns the storage and it owns the query engine portion of it. For Fabric, they essentially ripped out the storage engine behind SQL, and they completely reworked the query engine so that it's optimized for reading these Parquet files in the cloud. And the performance that they're getting out of it is almost unbelievable, how fast some of these queries are in these very, very large data sets, and how they were able to kind of get that SQL engine to do this is pretty interesting. Part of it has to do with again, while the Parquet files are open source, and any tool that can read Parquet can read these, there's nothing unique about it in that sense. The way that these files are written by these data engines, though, is in a very specific way. They call it V-ordered, and it mimics that kind of Vertipack engine's way of compression that Power BI has and tabular models inside of analysis services and stuff has. And that is what gives it some of this boost in performance. There's some more to it as well, but it becomes really important because it is this single backend format and data engine. So I do not need to move data around in order to do data science with it, in order to do reporting with it, or any of that. And we'll talk about how that plays into some of this in a moment. But it's very, very key to how all of this Fabric kind of platform works. So the next big kind of concept inside of Fabric is this idea of role-tailored experiences. So there is a design and development experience for a number of roles, and that's what all of these are. And we'll talk about each of these in a moment, just kind of briefly. But if you're a data engineer, there is a role for you. And not only is there a role for you, but the role is tailored to the tooling that you might use for that role. And it, again, being open as a backend, it allows you to bring third-party tooling in here to interface with it as well. And so we'll walk through, again, these each. So let's look at Data Factory first. So Data Factory has been in Azure for ages. It's gone through a number of iterations, but what is new here is primarily data flows. So originally in Data Factory, you have what was called a mapping data flow, and you had a data wrangling data flow. And the data wrangling data flow was very similar to the data flow concept that you had inside of Power BI. So this is being able to do record by record manipulation of data as it flows through the data flow. Well, that has been replaced. The mapping data flows are gone. They're completely gone. They're not even part of Data Factory in this world anymore. And it's been replaced by a new generation of the data flows from Power BI. So this is kind of that Power Query interface, but it's that Power Query interface that is essentially on steroids because it's been optimized for reading, writing, and interfacing with these Parquet files. And so it's very, very quick. It's very easy to use. And while Data Factory still exists as kind of a standalone tool in here, you will see as we go through these other developer experiences that the components of Data Factory have been integrated into those experiences. You're not expected, as let's say a data engineer, that I need to do some data movement. I'm not going to leave my data engineering experience to go to Data Factory to do this. Instead, I have aspects of that in my experience, and so I don't have to leave. But so Data Factory as a whole, though, is really geared towards any role. This could go all the way down to your kind of citizen developer because it is largely no code here. It's a drag and drop interface. It's relatively easy to understand, and you use it to build ingestion pipelines and so forth for your data. It is essentially the key kind of data movement service inside of Fabric. So next are Synapse Data Engineering. Really, this is built around Apache Spark, so it's that type of experience. This is what you would primarily use to build out lakehouses. This is what your primary interface for this would be a notebook. It supports a number of languages. which we'll talk about here in a little bit, but everything from Scala to PySpark to R is all supported in this environment. There's APIs in the back end that you can hook up third-party tools or even first-party tools like VS Code can directly interface with some of the Spark clusters that would be spun up as part of this process. And you could do your development in VS Code if you don't want to do it inside of the interface that they provide for you. The key assets here, though, are that lakehouse notebook, Spark jobs, and then data pipelines, again, borrowed from kind of the data factory side of it. And the roles being targeted primarily data engineers, but this is also an interface that data scientists may use as well. So data warehousing experience. This is clearly oriented towards data warehouse developers with kind of legacy skills and SQL engineers. It builds the same type of output. Again, it'll be a Parquet output, but it is managed through SQL. And you'll see the main assets here is the warehouse and the data pipeline. And so let's briefly look at what some of these differences are between a lakehouse, a warehouse, and there's also a legacy feature that's in Power BI Premium called data marts that are also somewhat related here. So from availability perspective, lakehouses and warehouses are available both in Fabric and Power BI Premium, where data marts is a Power BI Premium only feature. The data volume for this is in theory unlimited. It's keep scaling and scaling and scaling based on kind of what you have in your lake. There isn't really an upper limit on it in theory. Again, at some point, I'm sure you could exhaust Microsoft's data center if it's really truly a large amount of data. But where it starts becoming different here is when we look at the roles and how you interface with it. So again, if I am a data engineer, I am primarily going to be interfacing with these environments and creating a data lake through some sort of code in Spark. If I'm on the SQL Server side, I would be doing it through SQL statements. I can do a create table as an example. It has full kind of DDL support from a T-SQL kind of perspective. I have full query support. I also have full ability to modify from there. So it supports update statements, upserts, inserts, all of that sort of stuff was supported on the warehouse side, where that is not necessarily supported on the lakehouse side. If I need to insert data, I would likely be doing it, let's say, through a Python data frame or something like that, and I'm going to push it down into my lakehouse target. So there's the way that you interface with these environments is very, very different. So as a consequence of that is we have some differences in transactional support. I don't have the ability to do an update statement from a SQL perspective against my lakehouse. So I don't have multi-table transactions or any of that sort of thing involved here, where I do have that full support on the warehouse side. From a shortcut perspective, there's a little bit of difference here as well. I can mount essentially any file inside of my lakehouse. As long as I can read it with code, I can mount it and interface with it inside of my lakehouse. So the shortcut support is very wide, where on the warehouse side, everything is seen as a tabular object. So I have to actually have a table created on top of a file. So it needs to be very structured in order to do that kind of shortcut support. And then ultimately there's some differences in the cross query support, but a lot of that gets into the kind of the nuance of it. It isn't necessarily important for what we're talking about here. So let's move to the data science experience. Again, clearly oriented towards data scientists. Your main assets are going to be models, experiments, and notebooks. The big innovation here that isn't mentioned on this is that there's a number of new libraries that were released by Microsoft for being able to interface with these lakehouse and data warehouse assets, the Python and the underlying kind of Delta Lake structure, so you can read and write it more efficiently in Python. And then the other side of it is a new library called PySem. It's a library for actually being able to interface with Power BI data sets and manipulate them and refresh them and do a bunch of things. So from an open source perspective, there's a bunch of new Python tooling in this environment as well. So you can programmatically create a Power BI data model if you wanted. Moving forward some more, you also have this real-time experience, and it is geared towards that. It's geared towards streaming and time series kind of data sets. It really it shouldn't have the role data scientist here. I think that's a mistake on my part. It is based on kind of any sort of this real-time engineering. It could be IoT-based assets. It could be all sorts of stuff. We're not going to go into a lot of detail of what this is today, but it is based on Azure's Kusto kind of environment, or Data Explorer is another name that they use for it. So we have assets like a KQL database, KQL query sets, event streams, and so forth. There's also other open source things that play into this, like Kafka and other things that are part of this, but it's all geared towards being able to consume data in real time. So that brings us to Power BI. Power BI is largely not changing here. The main thing that is changing about Power BI is just the tight coupling and integration with Fabric. But the Power BI experience that you have today is largely the same as what you'd have in Fabric. The main difference is this new data access mode called Direct Lake. So right now inside of Power BI, you have two main data kind of interfaces. You have your in-memory models and you have your direct query models. And the first one, we bring the data inside of Power BI, it's stored in memory and we can query it very quickly. And the second, with direct query, the data lives behind in the database and Power BI just issues queries to that database and then we wait for the responses to come back. There is some hybrid between that where we can kind of mix and match and so forth, but those are the two main models. With Fabric, there's a new model, this Direct Lake model, where the Power BI data engine has been optimized again to read those lakehouses and warehouse assets. And it is very, very fast. It gives you performance similar to an in-memory model, but it doesn't require data movement like the direct query model. This is extremely important to this whole kind of ecosystem here, because again, it does not require data movement. I can just connect to a data lake, connect to the lakehouse inside of there, and immediately start querying things. And again, the performance for the aggregates and all of that stuff is like in memory. It's very, very, very quick.
Does it increase sorting aggregates? Refresh those occasionally?
Yes, there is caching that is occurring in the background. It's all outside of what you can see, but there's a fallback where it will go and fetch it. It's always checking to see that it has the latest data. But there is definitely caching that's occurring, and that's part of how it's getting some of this speed. But even if you connected it just raw to a warehouse asset, it is very, very fast. I'm not sure how they're achieving some of these speeds actually. It almost seems like magic in some cases. But for the bigger picture, you've done that query, it's now cached. The next user that hits it, it's just coming out of cache. And so it's instantaneous then. But it's very, very quick.
Even if it's on-prem, coming back in.
It's not going to be as quick because of the network latency and so forth. But it would still, in theory, cache it if you had the shortcut set up appropriately for that. So the way you think of it is the data is living somewhere in one lake. Again, it could be inside of actually Azure, could be AWS, could be on-prem, wherever. You then are building this kind of logical model on top of it. That's that lakehouse or warehouse that is defining all of it. And that usually is going to restore it in a format, that Parquet format, but in theory, some of those files or those tables could be remote to that. It could just be a virtual link through that shortcut. But whenever you again are doing that, it is slower. The benchmarks I've seen though are still pretty impressive. Well, these were benchmarks with AWS. They weren't any sort of local ones, but using an AWS storage at the back end and doing benchmarking, it was as fast as a native instance of Snowflake. So that is pretty impressive, given that there was no data movement needed.
Is there any access to control the cache?
No,
Settings?
nothing yet, at least. No, it is all automatic. So I don't think you would. If you're using Fabric, there really isn't much of a reason to build an in-memory model. You would primarily do that. There are reasons why they may do fallback. And so the direct lake, if it fails for some reason, it will fall back to a direct query model because we haven't really touched on this because there's a lot of technical detail under the hood on this stuff, but every one of those lake houses and warehouses has a SQL endpoint associated with it. So essentially a SQL server that I can query. And that is the fallback method for Power BI. It will connect to that SQL server and do a direct query if it can't resolve the direct lake for some reason. So the data is always accessible, but the data may be slow. And so if there's something in your environment, because there's file locking and things like that, that is causing problems, you may want to do an in-memory model then. But in general, you should be defaulting to a direct lake model first, and then have an excuse to go the other way. So Data Activator is a new product. It's currently in private preview. I believe it's still in private preview. I don't think it's hit public preview yet. And this is a new experience specifically around building triggers on data. It's kind of akin to something like Power Automate or something like that from the Power Platform, but it's very tightly, again, coupled with Fabric. And so any data inside of Fabric, I have the ability to develop what they call a reflex. And this reflex, I can define rules, thresholds. And so say inventory number falls below a certain threshold, it can then kick off a workflow of some sort and react to it. And it is designed in a way that it's all no code. And so it's really designed for business analysts to be able to kind of build these things as opposed to more of a, IT professional or something along those lines. But it's new, and it is there though. You can, if you sign up for the private preview, you can go kick the tires on it today. It's all available. So the next thing I wanted to get into is kind of this idea around that Microsoft is trying to sell here, that this is the unified data analytics platform for the AI era. For all of that kind of marketing, and you'll see it all over the pages about this, there really is no AI built into any of Fabric today outside of private preview. However, they do have a number of videos. If you go out to if you do a quick like Google for Microsoft Fabric, and you can just bring up the main Fabric page, there will be like about a 1.5, 2-minute video that kind of walks through the Copilot functionality that they're building into Fabric. And it is pretty impressive, but again, it's something that is not available right now today. It's not something you can easily kick the tires on. And it's not something that is even from a private preview perspective where you can just go sign up for it. It's an invite-only private preview at this point. And so very few people actually have insights into a lot of the workings of this. But we can talk about what it is trying to do. So they're taking a large language model AI, i.e. the same thing that ChatGPT is, and they're integrating it across the suite in this kind of branding called Copilot. And it allows us through natural language, just chatting with the AI, to integrate data, write code for us, analyze our code that we're writing inside of there to give us tips on how to improve it. Or if we're hitting errors, we can ask about the errors and it'll give us suggestions of how to fix it. We can use it to find insights across our data. And you can even use it to write reports for you. You can tell it what you want on the report and how you want it designed, and it will generate the report for you. The last thing is you also have the ability to customize these language models and integrate it with your own data sets and then publish that out as an OpenAI plugin that could, in theory, be used with other copilots in Microsoft's ecosystem, like the Microsoft 365 copilots or the GitHub copilots and things like that, or it could even in theory be used in any sort of custom OpenAI implementation. What they're showing and what they're doing here is pretty impressive, but again, it is not part of the platform right at this moment. It's all private preview. So All of this, though, brings us back to this concept that we've moved from this platform as a service into a software as a service. So we talked about it really briefly, like, can we manage things like cache and things like that? And the short answer is no on that, because this is meant to be a fully managed solution. We have the ability to configure things. So if I'm a data scientist and I need to spin up a Spark instance to do some experimentation work on, I get to define the specifications of that Spark instance, but I don't do anything except hit a button, wait a few seconds, and it appears for me. The other side of this is that there is end-to-end integration across the entire suite. So all the way from that bottom layer of the one lake, all the way through all of those other experiences. They're all interoperable. I can use assets, design, output from one in another one of the experiences and so on. I do have the ability to, again, as I was describing, centrally kind of configure my core enterprise capabilities. I can turn on and off features at an enterprise level and so forth. But again, it's managed for me. I'm just kind of hitting some dials saying this I want, I don't want that, or so on. The other side of this that it really goes into what we're going to talk about next with the pricing model is this idea of universal compute capacities, where in the past with all of these solutions, if I was spinning up a Spark instance, that's a different type of compute. If I spun up a Synapse data warehouse, that's another type of compute. If I'm doing Power BI data sets, that's yet another compute. And there's same with Azure ML, different compute there as well. And all of them are priced differently and so forth. This unifies all of that. The appropriate compute will be deployed for the job that you are doing, but it comes out of one universal capacity. And we'll, again, get into a little bit about that, but it's a little beyond kind of the scope of this talk as to how it's working in the background. But it leads to a simplified model. So instead of paying for a dozen different metered services, I pay for one. And this is what the pricing model looks like. There's two pricing models, and I know it's kind of small, so I'll read through some of it, but there's two pricing models. We have a first, which is the consumption model. I am paying for this at an hourly rate, and it's based on whatever kind of scale units I have deployed. It is elastic, though. I can scale up and down as needed. You can also have as many of these consumptions as you want. I could have a mixture of them. I could have several F8s, one F16, that sort of thing in this environment, but you pay for it on an hourly basis. When I say it's elastic, you also do have the ability to pause it. I can shut off a consumption for a period of time, so it's not incurring cost. But there is no real definition of what is inside of that consumption other than this concept of capacity units. And the capacity units are the equivalent of those numbers that are next to it.
Question.
Yep.
So this price includes the pricing for the other components you would do individually. It's basically a wrapper around it. Are you able to see what the consumption is for each individual part?
Yes. You get to see through the reporting, kind of the monitoring interface. And again, I want to be really clear. There's a ton of things in Fabric that I'm skipping over. We're not talking about any of the CI/CD stuff that's built into this for automation of deployments and so forth. We're not really talking about the management interfaces. We're not talking about how Purview is interfaced with this for all of the kind of policy and monitoring side. We're not talking about the one Lake Hub, which is essentially the new centralized lineage and data model for all of this. So you can see across it, there's a lot of components to this that we are very much skipping over because it's a very, very ambitious and very big platform. But there's usually something there for it. If you can think of it, there's something there. Now, how complete is it now, since this is just released? That's definitely questionable, but it's there in some fashion. But yes, you can see the type of compute that's being spent. You could see that your, data engineers are spending all of your compute on, Spark instances, and you're getting almost nothing left over for Power BI. But again, you can separate some of this. So you could create a dedicated capacity just for doing my executive reports so that they always have capacity available to them. But that first is this consumption model. The second is this concept of reserved instance. This is how Power BI Premium works today, where you are paying a flat monthly fee that's discounted for whatever SKU level that you have. There is some bursting capability where I can go up and then I would pay kind of that hourly rate to do the bursting, but I have a set fee for whatever kind of capacity I've agreed to. The pricing for this has not been announced. They initially said that they were going to announce this pricing here in August because that's when the initial free trial of this was set to end. They have extended that out to October. And so I don't expect to actually see the pricing probably until October timeframe, but it's expected to be on par with Power BI Premium. But what does that mean? This F64 right here, where you see that the price for that is $8,400 a month if you're paying hourly. That is the equivalent to a P1 instance in Power BI Premium today. And the Power BI Premium reserved price for that is $5,000 a month. So you're getting a few $1,000s off by reserving it, as opposed to doing the elastic consumption-based service. So that is what we would expect the pricing to be, is in somewhere in that ballpark. Maybe it'll change because it is subject to change, but that's kind of the idea behind it.
Have you found any way to like parameterize teammates or budget teammates, or does every intern get a blank check? Or have you seen anything to help you with that?
In general, a teammate would not have the ability to expand capacity.
Well, to use it.
Yes. So how that essentially works, and some of this is a little hard to test right now because in trial, it doesn't really cap you. It just kind of lets you spend whatever you want, and it's free at the moment. And so it's hard to see if you're actually, without going through some of the reporting, to see if you're hitting any of those kind of thresholds. But the way that it's supposed to work is, if I am running a job that's doing compute and I have exhausted my capacity, any other jobs then go in a queue. They don't fail, they go in a queue. And then the second the compute frees up, they would then process. But again, that can be a little frustrating because you'd be like, well, this job ran just fine yesterday. Why isn't it running? Why are we an hour behind today or something like that? So there isn't necessarily a good way of doing it other than some of the features that are built in, like that data activator that we talked about. You could definitely define some thresholds on that and notify someone if something like that happened. And there is an API for doing this in an automated fashion where you could increase scale or decrease it if you wanted to. But no, it's as far as how it's built right now today, there's no way of limiting one team experience from eating up all of your capacity.
You're right. They say they want to put everybody in their own big umbrella. They're trying to maybe funnel those workloads into separate capacities, right? Or fabric instances.
To some degree, yes.
With the data science capacity somewhere. But those
and I think you'd certainly see that from like kind of life cycle tiering, like dev and test and production, where you'd likely have different capacities for some of those things at different sizes. So this really is an evolution of all the stuff we were talking about earlier in terms of going from that decision support system up to the kind of the modern analytics models that we're seeing today. So the question kind of is, well, where is the revolutionary part of this? Where's the revolution of it? And there's three kind of areas that I have you look at. And the one is this end-to-end vision. Microsoft is in a very unique spot where they own the entirety of this from that moment of actually even before ingestion, because they likely own your OS all the way through to your productivity suite with Office and Teams and all of that sort of thing. And they have every other component in between through Azure. And in addition to that, when we do start talking about some of the AI elements, they are doing massive investments in that AI side of things. There isn't really another competitor out there that has that breadth of capability. So if you look at something like Databricks as an example, they're extremely strong when it comes to the data lake side of this. And they are acquiring things to improve their portfolio and all of that stuff, but it's still very, very narrow. And I can't think of another competitor out there that has this ability. Because even you look at someone like Amazon with owning AWS, yes, they have that whole backend infrastructure, but they do not have the productivity or the OS and a lot of those components that go into this either. They don't have a good competitor for something like Power BI either as well. And so this completeness of this end-to-end vision is going to be extremely difficult to compete with if Microsoft is able to pull this off. And it's one of the big differences that I've seen in this too, comparatively to how Microsoft has worked in the past. They tend to be a very siloed organization where the Azure team's doing one thing, the M365 team's doing another thing, and they all kind of live within their little silos. For this, they really have tore down a lot of those walls and are kind of forcing everyone to play nice with each other by this kind of second pillar, embracing these kind of open standards. So there is no more, SQL Server data engine. It's gone from this perspective. It is Parquet and that Delta framework. And you're just expected as the SQL Server team that you are going to make this work somehow. Similar with Power BI and so forth. It's like, here's what we're embracing. Here's the standards. Figure it out. This also, though, still allows us to embrace some of the things I mentioned earlier around the modularity of this. This is open to third parties. There's no reason why you couldn't use Databricks to write out your data lakehouse. It's just Parquet. They could write to it. They can read it. There's no reason why you can't have third-party contributions here or community contributions to extend this system. And then the last side of this, and we did talk about some of the problems with this, is the idea of universal compute is how do we control who is stealing what from that kind of middle pool. But at the same time, this is a really interesting concept because right now in this kind of platform-based service, we have a lot of competing compute. I may have an environment that has Databricks and Snowflake, and they both have their own compute engines that are not necessarily compatible with each other, that are doing proprietary things. Well, Databricks is open, but Snowflake is not necessarily open. And I don't have a way to simplify that model in terms of pricing. It gets complicated.
Is there a way to access the metadata, or have they made any comments about bid management?
Yeah. So the second one, have they made any comments about master data management? The answer is no on that right now. But is there ways to access the metadata? Yes. So the metadata, that one hub that I mentioned earlier, it has an API that's based on Apache Atlas at the back end. So any Atlas compatible metadata tool can access it and write to it in theory as well. So that kind of goes back to this embracing of standards. There isn't a layer in here that doesn't have some sort of either emulation of an open standard or actually based on an open standard. It's, like the OneLake, it's not open, it's all proprietary, but it does expose itself as a Hadoop file system. So in theory, Hadoop file system compatible tooling can write to it. So that's kind of the mixture of how they're handling some of these standards. Sometimes when it is a proprietary technology, like the hub side that we just talked about, it will be augmented with an open source API. So, but yes, the short answer is you can interface with some of that. So a quick sales pitch. If you'd like to learn more, my team does data and AI solutions. There's three kind of main things that you may be interested in. One is we can bring kind of educational series like this to your organization in the form of lunch and learns. We do those sort of things for free just to help educate you guys on what is coming and what's available. We also have a solution offering around this kind of concept of jump starting these things for Microsoft Fabric. We actually have a couple. Some are focused on back end, some are focused more on the front end, but it's meant to take a small kind of pilot project, get it going with your organization so you can kick the tires, see how it works. There's education mixed into that too. There's training involved with it so that your team owns it when it's done. And then last, that might be of interest in this space is we do just general advisory services as well, where we can do kind of a data architect as a service where we can come and augment your team, bounce ideas off of us, that sort of thing, just to help explore how you may want to do some of these. And just quick about us, Covenant Technology Partners. We are Microsoft solution partner. We have three kind of primary tiers of service that we do. We do managed services where we manage your infrastructure and environment. We do software licensing through our CSP program. And then ultimately my side of the house is business solutions, so classic consulting services, that sort of thing. Back to the program as is though. What questions do you guys have about Fabric?
If you have any questions on the online, if you want to put them in chat, that'd be great.
What happens to just straight SQL developers?
Well, there's definitely a role for just straight SQL developers in that warehouse side of this world. And as I did mention, as every one of these kind of data assets in the lake does have a SQL endpoint associated with it, where you can write SQL to it. It's just, it might be a limited plane, like for instance, that lakehouse interface. I can really just do select queries against it. And that's about it. There's a few extra things. I can write custom stored procedures and some of those type of things on it. But even there, the stored procedure is just going to contain select statements inside of it. So it doesn't necessarily go away, but probably the bigger side of this is that this is really only analytic focused. So the operational side of this lives outside of Fabric. It would just be feeding data into Fabric somehow. So SQL Server as a product is in no danger of going away. It's just SQL Server as part of this analytics solution. It's really just a query engine at this point.
All right, we have some questions. SharePoint was kind of skipped a bit, and I don't know how strong it is in other people's works, but just a normal first class data source.
No. At least as of right now, there's no way to like create a shortcut into your OneLake with like a SharePoint list or anything like that. Now you, from like Data Factory or any of those other kind of data movement services we talked about, they can all talk to SharePoint just fine and pull data from it. But I don't really have the way of creating that shortcut yet. But you know, as I alluded to earlier, they seem to be positioning this as a bit of a replacement for OneDrive. I don't think it'll be a long-term replacement for OneDrive, in that OneDrive is also about kind of your personal side of it, and OneLake is not meant to be personal. It's meant to be a organization-wide. Maybe you can lock it down to a team workspace, but there isn't really your personal workspace inside of OneLake, like that you might have with OneDrive for backing up your documents and things like that. Maybe that'll change at some point. Maybe they'll integrate it there, because it does seem a little silly to kind of have both when there's no limitation from storing files inside of the lake. They could be any type of file. It doesn't have to be an analytic file. So you could definitely push it there, but I don't know how that'll work again with things like lists and other data that's stored inside of SharePoint. One of the things that we didn't spend much time talking about is the kind of the evolution of a set of tools that's in Synapse today. They're called Synapse links. And there's a Synapse link for SQL, there's a Synapse link for Dynamics, there's Synapse links for Cosmos DB and things like that. Those are all getting ported over to be able to do change data capture directly to OneLake. So as you update a SQL table, it just automatically is writing a copy of it in a lazy manner to the OneLake. So we don't have to go fetch from the database directly. It'll just appear. And it's the same with like all the Dynamics tools like F&O and CE and those type of things. They're getting integrated directly with it. But most of that tooling is either not there yet, or it's in private preview, because they haven't converted it from the Synapse model over to the Fabric model yet.
Cube data and like MDX, any big noteworthy, any as big still used?
No, I mean, the backend engine of Power BI is still analysis services tabular model. And now that's not going to go away. But at the same time, with the move towards things like this direct lake and stuff like that, it reduces the need for it to some degree, for sure. But there is no like analysis services as part of Fabric. Again, in theory, you could load some data from your lake into analysis services, but the question would be why? What are you getting out of it at that point? So the other side of it, just from a query engine perspective, I mean, the primary language for Power BI is still DAX, which would be what is on analysis services tabular side. There's no MDX side of this at all anymore, but those components are still living on. They're just living in a new form.
And I mean, the notebooks and Spark seems
Yes.
to be the focus. I've been having a lot of fun with the .NET kernels on Polyglot notebooks.
They're all gone.
Seen any mention of anybody trying to bring that in?
So there's a problem with the latest kind of supported Spark kernel in Azure in general. It has nothing to do with Fabric. That the team that manages the open source version, the Spark version of C#, the .NET side, is outside of Microsoft. It's community run now, and there was some sort of lag with them getting it updated to the latest Spark kernel, and Microsoft just decided to drop it. And they're saying, at least as of right now, that they have no plans of bringing it back. So, yeah.
It becomes everything.
Yeah, or Scala or R. But yeah, it's primarily from a first-class citizen in this environment, it would be Python. Python has the most support. Other questions?
Is there a defined process for relating all this disparate data that exists in one lake? I bring in files and I bring in web services. Like today in Power BI, you have to define all those relationships. Is there a defined process? Is that necessary?
Absolutely. But it really kind of goes beyond the scope of something like Fabric, or even like what we were talking about earlier with the modern kind of analytics. It comes down more to how you're going to organize this. So like how we've been doing it in Synapse for the last couple of years is we do it with kind of this concept of zoning, and it's very similar to what most of the industry would call that kind of medallion system, where you have bronze, silver, gold kind of layers in your lake. But we're doing it a little more purpose-built. So our initial is like a landing zone, just raw data lands there. It's transient. You don't report on it because it could change at any moment. That would then go into more of a consolidation zone that is kind of akin to a operational data store. And that operational data store is still largely raw, but it is no longer transient. It's permanent in that space, and we'll just be augmenting it. And we have the ability to enhance it with things like crosswalks. So I have CRM data in there and I have an ERP data, and I need to have crosswalks so I can map customer to customer or something like that. But again, it's largely just still an operational system at that point. So that would be more akin to like a silver kind of medallion layer. And then it splits a little bit from our model. We would go into things like a sandbox for doing things like data science experimentation, things like that, or versus more of a formal lakehouse where now I'm going to remodel it and start consolidating. I have one view of customer instead of my CRM and my ERP view, right? And that starts becoming your gold or even platinum kind of layer. And there's other layers involved here. We usually have like a data exchange. This is for sending data out to partners, vendors, things like that. So it's kind of a bi-directional exchange of data and things like that. It's all design wise. There's nothing inside of Fabric that really dictates this. It more has to do with your governance and policies and procedures and stuff and how you organize and lay out that data. So hopefully that answers that. Others? Any questions from people online?
No, I don't see any online questions. I was remiss at the beginning.
Yeah, I know, it's just that, appreciate what's time. Thanks for contact, hopefully the contact, actually, that's questions, several folks did, that can answer questions as well. So.
You want to say something about coordinating?
No, we're just very happy to always be able to, you guys here, have these presentations and be able to provide this information and space for everyone.
We really appreciate the meeting room and the space. It's a wonderful, acceptable location for us.
And having
Jordy, having here. This is the highest attended presentation for the past meeting, including in person for the past 2 years. So
thank you very much.
So hopefully though, this information was useful to you guys. It really is hard to cover everything here because it really is a super ambitious project.